The instrument used by water providers to size and count particles in water is the particle counter. Particle counting has been long used in medicine, manufacturing, and electronics, and is today a valuable tool for water supply operators. Particle counting gives more detailed information than does turbidity, within similar measuring. For example, if you have a reading of 1 turbidity unit in a water sample, that reading could have been created by 1 large particle, or it could have been created by 1,000 small particles. While turbidity is a qualitative measurement of the amount of particulate matter in water, particle counters provide quantitative data on the size and number of the particles themselves. The additional information allows operators to make adjustments to treatment process. Particle counters provide more information than turbidimeters because particles are individually sized and counted. In a conventional filtration plant, the small submicron particles generally break through first, followed later by Giardia-sized particles. Therefore, particle breakthrough is often a good predictor of turbidity breakthrough. There is lots of research demonstrating that turbidity removal is a good surrogate for Giardia removal in a conventional filtration process. In fact, that is the underlying basis for the treatment technique requirements of the surface water treatment rule. Research has shown Giardia-sized particles may pass through the treatment process with no increase in filtered water turbidity readings. That's because small concentrations of micron-sized particles scatter very little light. Here, a closer examination of the particles is necessary. Particle counters are most useful on the effluent of a filter. One can generally see the breakthrough of small particles before one can see breakthrough of turbidity. So often an operator will watch a trend of particle counts along with a trend of turbidity. Often one can see a rise in particle counts before a rise in turbidity, and then an operator knows that the filter probably has to be backwashed. Particle counters combine particle detection technology with electronic counting technology. They operate by passing a very fine stream of sample water past a laser or light source. The light that is blocked or diffused by passing particles is measured by a photodiode or sensor, and the signal is interpreted by a computer. The most popular types of particle counters used by water utilities are batch and online. With batch particle counters, sample water is collected in a container, and the particle counter's sampler draws water from the sample to create flow through the sensor. Online particle counters draw water continuously from the sample location through tubing that's connected directly to the sensor. A flow controller is required to regulate the flow of the sample. The most important requirement for using online particle counters is to maintain a specified flow rate. The flow must be constant and at or near the sensor's calibrated flow rate. Manufacturers offer a wide range of flow rates. Particle counters should be calibrated to match the flow rate of the plant's selected sample point. Particle counters also need to be calibrated so sensors will provide accurate particle size and shape readings. This is done by using calibration spheres of known size and refractive index. Online particle count data can be expressed in total particle counts, volume concentration, differential counts, particle size distribution, log removal, and percent filter efficacy. Water professionals say the information particle counters provide can have a significant impact on the entire water treatment process. The pathogens utilities are generally most concerned about are Giardia and Cryptosporidium. They represent particles in the 2 to 10 micron size range. By carefully watching the number of those particles, an operator can optimize coagulant dosage to minimize the number of crypto and Giardia-sized particles that will pass out of the filter. Another important reason is that there isn't a universal standard for calibration of particle counters. There is an ASTM standard. All turbidimeters can be calibrated so that their results match. A water sample measured on one device will give the same result on another device. There isn't such a standard available for particle counters at this time.